What's up, Internet? It is I again, that guy again, and today we're going to continue our Kingdom Hearts 2 hack through. We're on like part 8 now already, which is kind of crazy to imagine. We're still in Twilight Town, but you know how it goes. Today, we're actually going to jump right into the meat and potatoes of things, right? Because last episode, there at the end there, we learned that each entity from a offset of A90 contains a 4-byte short pointer. And that short pointer, hold up, we gotta go to the, is that the right address? Yeah. So we'll go plus A90, right? It's either 0 or non-zero, right? In this case, it's non-zero, and that's our short pointer to the next entity. So with this information, right, we want to be able to go through and look at all of the entities in a room and see whatever we want to, like how we can see Sora's info here. We just want to be able to see, information for any entity, right? So we'll do a couple things. We're actually going to go and we're going to edit our, would you call it, pointer convert script first, right? And we're going to grab a couple things into just a little notepad, because this is the one that's going to convert the function that'll convert a 4-byte pointer to an 8-byte pointer. So that's one of the things we'll want. And then we also need to grab that from G-Hydra. We need to grab the pointer that leads to the first entity. Copy. And we'll just test it out real quick too to be sure. Here, it's personal preference, but I like to have it all capitalized. You really don't have to. But like if we go here, memory view, and we go Control G, paste that, there we go, it's a pointer to the first entity, assumably. Awesome. So that's going to be, we'll call it entity base pointer. Alright, sick. And then basically what we'll do is we're just going to start there, and then for every, what would you say, like for every entity that we're going to iterate through, we just iterate through to find the next entity. You'll have to see it. This is going to be more of a seeing is believing kind of thing. But the other thing we're going to grab is we're going to grab this address right here, which is where we actually found to hook our pointer convert into, right? And the reason we want to do that or use that is this is going to be code that we've already found to get called like every frame. And what I like to do is go ahead and enable pointer convert so we can actually see like where the jump is structured, and we can make sure that if we're writing additional code, it's not going to just accidentally overwrite it or anything like that. So let's see. Usually I don't like to do stuff like right in front of jumps or anything because it can break jumps, but I think Cheat Engine automatically handles that, so that's cool. Here, let's just say right here, right? Let's just go over here. Does this run multiple times? It does. Awesome. So what we'll do, we'll say like right here, we'll overwrite this call. Cheat table framework code, code injection, just like that, right? So for what we're going to do here, we're going to want to actually allocate some memory for us to be able to store variables, right? And there's really 3 named variables I can think about, or namely 3 variables I could think about we would want. 2 of those are going to be 4 bytes, and 1 of those will be 8 bytes. The 2 4-byte variables, one of which is going to be the ID, so to speak, of our selected entity that we want to view. And the other one, we're going to have it basically tell us the maximum amount of all entities. And then the 8-byte one is going to be a pointer to the selected entity. So the way we'll start this out is we're going to say allocate entity info, right? And we're going to want the first part, it's 2 4 bytes and an 8 byte, so it's going to be a total of 16 bytes. Really, it doesn't matter where we store this near, so we're going to leave the third parameter blank. And then right after that, we're going to want to say register symbol entity info, so that we can refer to that in our cheat table later. And then under the disable area, I think it's unregister symbol. Yeah, there we go. I always do deregister symbol, and that's not right, it's unregister symbol, because entity info, because see with alloc, it's alloc and dealloc. So that's why I think that, but that's why you don't want to think that, because it won't work if you do it that way. So yeah, this is how we get it to work. And then at the start of our code, we're just going to go ahead and push the A register, push the C register, We may as well go ahead and push the D register. We might want to push the B register, but we'll come back to that later. Because what we're going to do immediately after is, so there's a couple things we'll need to do. And actually, yeah, we're going to go ahead and we're going to push the B register also. Apologies, y'all. My cats are deciding to go insane today, so if there's a lot of choppiness in the recording, that's why. Something we'll also go ahead and do, though, is we're going to go up here, and I would say we want to make a label. We're going to call it entity loop, right? And this will make sense soon. But what we have to go ahead and figure out is the structure. And I think what we'll do is the way that we're going to organize our 16 bytes for entity info is we're going to have it to where basically the first 4 bytes are going to be the size, right? The size of the entity. The next 4 bytes are going to be the index of the selected entity, right? So that's going to be like 1, 0, 2, you know, which entity you want to actually try to access. And then what we'll do after that is going to be the 8-byte pointer actually leading to that entity, right? And so what I think we'll do to start ourselves off, because we need to preserve the C register so that we can push, when we call the function, we can push the 4 bytes there. So, all right, so I think what we'll do is we're going to use the A register to store the current entity that we're on, right? And so to that effect, the way we're going to get the first entity is we're going to use a move instruction instead of an LEA instruction, right? Which is important because this is a pointer. This is an 8-byte pointer at this address that leads to an entity, right? So we're just going to take that, move into RAX, the value stored there. Very good. And so now, at this point, we're going to have the 0th entity, and I think the B register is probably where we're going to want to store that. No real rhyme or reason, it just seems nice. It seems like a cool place, you know, cool enough place. So XOR RBX to go ahead and set that to 0, because that's just going to be the counter, right? That's going to be like, what are we currently on? And then I think RDX we're going to set as the basically the index, right? Where we're going to keep track of like which one the player or the user, so to speak, is actually looking for. So for that, we're going to move into, it would really be EDX because it's going to be a 4-byte value. And we're just going to take entity info plus 4 because the 0th one is going to be the size of the entity. All right, so now that we've got that where it needs to be, that's going to be the one that we're trying to look for. We're going to actually have our entity loop, right? And that's how we define that. And so I might also say, make a label called loop exit, right? And we'll actually just go down here and say loop exit. And then, well, one thing we'll say when we exit the loop, right? Because the loop is only going to exit once we reach the very end, basically. Like once we find the last entity in the entire list. And so at that point, we need to go ahead and say that the RBX register, right, the one that we set to 0, that one's actually going to contain the amount of entities we found, right? And yeah, so what we'll say is we're just going to say move the entity info RBX EBX, yeah. So it's going to set the 4 bytes of entity info to the value stored in the EBX register, sorry. All right, so now here's where we actually get to the meat and potatoes. So every loop, which this is running every single frame basically, right? So what we're going to say is we're going to want to take, we recognize that in the D register, that's where we've got the index for what we're actually looking for. And the B register, that's the one that we're actually on right now, right? And so what we're going to say is we're basically going to go ahead and we're going to compare EBX to EDX, right? And normally what you would say is you would just say like, hey, if these are equal, then we're going to jump to this code that handles them being equal. But with the way that we're set up here, it's actually a little bit easier for us to go up here, make another label, and say like label not equal or something simple like that, right? And we're just going to say like jump if not equal to not equal, right? And then down here we're going to have not equal. Now in this case, this means that they were equal, right? And if we basically, in this case, we found what we're looking for, then we already know the A register is going to have the memory address of the entity that we're targeting. So in that case, we're going to just simply want to say move entity info plus 8 RAX. So it'll move that pointer in there, right? And then after that, we're still going to have to continue with the loop because the loop is also tracking the size of the entity array, or the entity linked list, I guess you would say. So in that case, we're actually going to want to increment EBX. And then I believe after that, jump entity loop. There's actually something else we'll fix in a second. We're actually ignoring the, yeah, we're ignoring something here. That's okay. That's okay. We're going to just go ahead and make a divot here. Yeah, there we go. And as far as not equal, right, if they're not equal, all we're really needing to do is increment EBX. And actually, we can do something for efficiency's sake here. Go ahead and compare them. Increment EBX there. Jump not equal. Boom. If it is equal, we do that. There we go. All right. So instead, it's gonna, at some point in the entity loop, it's gonna check and see if we're on the targeted entity, and then it's gonna go ahead and increment the V register either way, because it's gonna have to do that afterwards anyway, right? We're gonna jump if not equal to not equal. Otherwise, we're gonna go ahead and say, hey, this is the one we want. We're gonna move the address of this to the area memory we've designated for that address, for the entity address. And then either way, whether it's not equal or not, we have to jump back up to the loop. So we're just going to handle that there. And so now, let's see. I might actually do something different because we went ahead and we incremented EBX here. So what we'll do here is we're going to say move into ECX RAX plus A90, which is the supposedly, what would you say? It's supposed to be the entity address for the next entity, right? Up here, we're going to go ahead and we're going to say comp ECX0, jump 0 to loop exit. So if we ever hit something that's 0, we're just immediately a loop exit. And actually, I'm going to do this a different way altogether. Do this an entirely different way, because here we're going to go ahead and use our call instruction. And if I recall, it was only the C and the A registers that were impacted, so we should be okay. But just go ahead and call that, because that's immediately going to put in the A register the address for the next entity. Up here, we can just say compare RAX 0, jump of 0 to loop exit. I want to say this will work, but really the only way to find out is to try it. That was risky. So let's go ahead and try it, right? Let's go ahead, assign to current cheat table, right? We're going to go ahead, we're going to create a group, and we're going to say entity info will be the name of the group. Yeah, we want address version. We're just going to set it to the address of entity info. Rename this to enable, because that's the actual cheat. Group config, hide children when deactivated, drag it up to the top. And then sometimes I find it difficult to get stuff to go in there, so I just like copy and paste. And then now that there's like an extra entry, I can just drag it in there. And I actually fucked up because that was a group, so we're going to do that. Very good, delete all that. All right, cool. So the first was like the, what were we saying? Entity count, right? Supposedly. Plus 0, awesome. Copy paste, change count to ID. Go by 4. Here we go. And we'll just go ahead, entity. Really, this next one needs to be group. So what I'm going to do, if we look at Sora entity, yeah, mset short pointer was a plus 4, I think, plus 8. So let's just do this. Let's copy mset short pointer. Let's just paste it in here, right? And we're going to add this to a group. Entity, right? Yeah, we want address version. Drag entity into this little area. Make sure it goes under there. Group config, hide when deactivated. And we're going to set it to plus 8 pointer. go. Alright, so let's see if this crashes. Okay, no crash. No crash at all. Let me just see something real quick. Remove offset. Okay. Let me just look at something here. Sometimes it's hard to write code in assembly, so, you know, forgive me if I messed up and all that, but let's see. Because it's almost like it's just never writing into that memory address. So we're going to go and edit script or change script because it needs to be writing into this. Jumping. Maybe it's something with this increment. Tinfo plus 4 would be that if they're equal. Jump if not equal to that. So like, what if they're equal though? What if they're equal? What if we enable it? Plus 4. And then at the moment that we find them to be equal, move Rex in there. Rex can't be equal to 0. So it might be something. The only thing I'm seeing is this inc EBX. Maybe it's tripping some flag. So maybe what we need to do instead, because actually, funnily enough, down here, it's going to end up here anyway. That's something where we spaghetti coded ourselves. So it's going to hit entity loop, check if we're at a 0 entity. If so, we exit the loop. If not, check if we're on the one we're wanting to find info on. If we are, then we move that value to where we're checking for the info at. Otherwise, continue pushing, continue pushing. All right, cool. That looks about right, actually. So save, just disable, re-enable, set this to 1. Is this doing anything? Oh, I think it is. I think it actually is doing something, maybe. I see one thing in here. Hold up. Pointer. Okay. We're getting closer to our goal. Let's do this, right? Break on right. Let's see what it's doing. Because where we're at, let's actually just set a breakpoint right here and run. Okay. So we move that in there. That's going to be, yep. Set bx to 0. Yep. Move the value there into RDX. Right now that's 0. That should be the target entity. Yep, that is. Compare it with 0. 0 flag is 0. Compare those two. 0 and 0. So it should be good. Yep, and it looks like it's working. So we store the value there and we continue pushing. Right. So let's do this though. Entity ID, set that to like 1, right? Because we're back up. Huh. Wait a minute. We didn't loop, did we? We didn't loop at all. That's a problem. We should have looped. Only when we go to loop exit should we. Unless there weren't actually like 9 or something. I don't know. Let's see. We still have that breakpoint, right? Yeah, we do. Okay. Let's do this, right? Because we have. Okay, cool. Yeah, so this is making sense. We are looping. I was just crazy. Okay, sick. So let's go over here. We have 1 in the DX register. Yep, so that's what we want. Now they're equal. Compare them. Jump if not equal. Wait a second. The DX register has D560 in there. Something ain't right about that. Because that's why it's not saying it is equal anymore if it's non-zero. Okay, so let's do this, right? I wonder if it's this function we're calling that's giving us issues. What's happening to our D register? for some reason DX has. This is one of those where in the world did that come from things. Because, okay, so the first time it's RDX, and then as soon as it goes through, it changes to this other address. And we're not intentionally modifying this. Alright, so RDX is 1. Let's just keep going. Let's see what's writing in RDX. It's that damn function. It's that damn... So for some reason, it only writes in RDX in very specific instances. Okay. It's fine by me. So all we got to do to fix that is right here, push RDX and pop RDX. Call it a day. Make it easy, right? There we go. Disable, enable. All right. And just like that, we now have the ability to step through different entities. And some of them might have the same like mset short pointer or whatever. That's cool. Not worried about that. But we have the basis of our entity viewer, and the cool thing about that is we can actually like hook into it. We can make something that allows us to do an mset short pointer viewer with the same thing and so on and so forth, but we'll get to that another time. What I will go ahead and do, just because it's easy, is we can literally just go ahead and copy paste that page. Like that's just literal copy paste work. Boom. So we can see, and we can do something with the party stat page short pointer later. So now, I mean, X, Y, and Z we can put in there, but I'm kind of wary because we don't know enough about those yet. But that's all good. That's all good. So now, if we wanted to go, let's say, 1. Okay, so some things just don't have stat pages, is what it is. So if it's not like actually a party member or whatever, I guess. You know, I wonder something though, right? Let's try this. Let's try this. Let's go and like, because Roxas is probably the first one, right? Let's take an mset short pointer from something else and put it on Roxas. What do it do? Oh, it just makes them silent. Let's load a room. See if it crashes. No, everything seems back to normal. Oh well. Well guys, that was a little bit more of a technical video than normal. We'll do some more with this next time, but until then, I appreciate y'all and see you.